So this is chapter 2, IM-1 grade repair test recovery. This is day 1, so this is video 1. We are going to do 3 lessons today. Where it says name, please write your name. And then where it says teacher, I want you to write my name. So I'm Mrs. Torkelson. But then I also want you to write your math teacher. So if that's Mr. New, Miss Dew, Mrs. Robinson, Mr. Lopez, myself, you could write Mrs. Torkelson or Miss Rubio. So if you have any of those teachers, please write their name here so that I know who you have as your teacher. Okay, perfect. So let's start with 2.1. So the first lesson that we're going to talk about today is building functions. And so right off the bat, we're talking about tiles. So we're talking about figure number and the number of tiles. So I have a table that's already filled out, but you see these arrows at the bottom. I want to figure out what each column is changing by to get to the next term. So if I start at 60 and I go to 56, it's decreasing. So I'm subtracting, and I'm actually subtracting by 4. So it's minus 4 tiles every single time. Then on the top, it looks like I'm adding by 1. So each figure number is increasing by 1. All right, what is the starting number of tiles? So what is t of 0? So wherever x equals 0, this is the same thing as x equals 0. So I'm going to look at my table. Well, it's not x in this case, it's n. So n equals 0 right here. And so that's going to be 60 tiles. All right, growth rate is just a fancy word for slope or your change. So what is the growth rate of the tiles in relationship to the figure number? So we have to talk about the top row, but also the bottom row. So the top number is going up by 1, or the top row, and the bottom row is going down by 4. So we can say something like, for every unit increase in figure number, the total number of tiles decreases by 4. So you have to be very specific. You have to talk about the figure number and the relationship between that and the number of tiles. So that's why we write about both. All right, part C says write a rule for this pattern in function notation. Remember, rule just means equation, and be careful because your problem tells you what letters to use. So I'm going to use these letters or these variables. Normally we write it in the form of y equals mx plus b, but I'm going to use the letters, that they give me. So instead of y, I'm going to write t of n. Instead of m, I want to talk about what my change is, and I'm changing by -4 each time, so that's my m. My x is not x, my x here is represented by the letter n. And then my b is my start. We said the starting number of tiles was 60, so plus 60. All right, part D says graph the data from your table. So the x-axis already has numbers on it, and it's represented by my figure number. I just have to come up with the numbers for my y-axis, or my t of n, which is the number of tiles. I have to make sure that I go all the way up to 60. So you can try different numbers, but I think the best route here is to go up by 6. So this is 0, 6, okay, then I have 12, 18, 24, 30, 36, 42, 48, 54, 60, and 66. So we want to make sure we go all the way to 60, and then once we get to 60, we have to keep that axis going. Okay, perfect. Then I'm going to plot my points on my graph. Do your best, because for some of these we are going to have to round a little. So for example, 0, 60 I can plot on here, so let me use a different color. The 0, 60 is right here. And then 156, so like here, do your best to think about where that goes. I'm gonna say it's like right here. Then I have 252, same thing, do your best. I'm gonna say like right here. 348, so that's right here. And then you need at least 3 dots. We can do all of them though, so I'm gonna do 444. And then my last one is 540. So 540 is like right here. Then I'm going to use my ruler to connect all of those. This dot, I'm going to move a little bit further down just so that it lines up better with my line. I can just make it a little bit bigger. All right. So those are the dots for my table and they're graphed now on my graph. All right, part E is how's the growth rate of the tile pattern represented in the graph? So it's very similar to part B, so you have to talk about the figure number and the number of tiles. So for this one, we can say with each figure, so with each figure number, the total number of tiles decreases by 4. So it's the same type of sentence. Each figure number is going up by 1, and with each one, as I increase, my tiles decrease by 4. So, and I can see that, right, because my line is descending, it's going down. All right, part F says, how many tiles will there be in the 10th figure? Show your work. This is asking for the figure. Remember, figure is represented by the letter N. So for this one, N equals 10. I'm going to use the equation that I'm created up above in part C. So I'm just going to rewrite it here. And anywhere that I see the letter N, so I see it in 2 spots, I'm going to replace it with the number 10. So I have T of 10 equals -4 times 10 plus 60. Then that -4 times 10 plus 60 will just go into my calculator. So let me plug that in. So this is all calculator right here. So -4 times 10 plus 60, I get 20. So T of 10 equals 20. So now I can write my sentence. The 10th figure will have 20 tiles. Okay, now I'm going to focus on part G. It says, which figure number will have 0 tiles? Show or explain how you know. So this is the opposite. This isn't asking me which figure. This is not n equals. This is asking me to solve for n. So it's telling me my t of n. It's telling me that t of n is 0. So in the same equation that I used up above, so I'm going to rewrite it. This time, I'm not replacing the n. This time, I'm replacing t of n. So instead of those letters or those variables, I'm going to have 0. Everything else will stay the same. So essentially, I'm solving for n because I want to figure out the figure number. So this is a 2-step equation. I'm going to subtract 60 on both sides. And then I'll continue my work over here. So 0 minus 60, negative 60, equals negative 4n. I'm going to divide by negative 4. And negative 60 divided by negative 4, I get 15. So the 15th figure will have 0 tiles. Okay, so I'm going to write a sentence saying that. So the 15th figure will have 15, or will have 0 tiles, not 15 tiles. Okay, perfect. Once you finish your sentence, let's turn to the next page. And now we're going to focus on 2.2, which is building functions with context. So now we're doing the same thing we did on the first page, but now we're talking about context, which just means like a real world situation. So we're going to talk about a dog. So Barbara has a dog that weighs 5 pounds and gains 3 pounds per year. Okay, so at the start, the dog weighs 5 pounds. So at the very beginning, the dog already weighs 5 pounds, like when it's born, right? It's a puppy. Per year is every year, so every 1. So my number of years is increasing by 1. And the dog gains 3 pounds. So my pounds, I'm gaining 3 pounds. Let me fill in the rest of my table. So then this will be 8, 11, 14, and 17. Okay, we've talked about in this chapter to find your m or to find your slope, it's always your y over your x. Okay, so I'm going to stress that almost in every video because we're going to use that almost every single time. So I want to find my change in y and my change in x. So my change in x, if I look here, my change in x, I'm adding 1. So this is plus 1. My change in y, I'm adding 3. So this is plus 3. Okay, in order to figure out what my slope is, I'm always going to do my y over my x. I know that my y is 3, so I'm going to write plus 3. I know that my x is 1, so I'm going to write plus 1. The last thing I'm going to do is divide those and see if it simplifies into something smaller. So 3 divided by 1, I get 3. So my m here is 3. That will be helpful later on. Okay, perfect. So now part B says use the table to make a graph. So then here's my graph. There's no numbers this time, so I have to come up with all the numbers. I know that my x-axis is the number of years. And I know that my y-axis is the weight of the dog in pounds. So weight of dog in pounds. For my x-axis, since it's going up by ones, I'm also going to go up by ones. So this is 0, 1, 2, 3, 4, 5, 6, 7. And then for my y, I have to go all the way to 17. So I'm going to try to go by 2s. 1s won't fit. So I'm going to try 2s and see if that works. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18. Perfect. Then I'm going to plot my points here on my graph. So this first one is at 0, 5. So 0, 5 is right here. And then I have 1, 8, 2, 11, 3, 14, and 4, 17. Then I'm going to use my ruler to connect them to make a straight line. Okay, perfect. And it's increasing, right? So my dog's clearly gaining weight, and I can see that because it's a positive slope. So part C says use the table to determine how much the dog will weigh in 5 years. So here's my table, but I stop at year 4. So I need to go up 1 more year. So I'm just going to continue my table, and then I get 5. Okay, if I continue my table, that means I'm continuing to add by 3. So if I add by 3, 17 plus 3, I get 20. So in 5 years, the dog is going to weigh 20 pounds. And so let me write a sentence. So in 5 years, the dog will weigh 20 pounds. Part D says write the rule for the pattern in the table above using function notation. So always look at the letters or the variables that your problem uses. Function notation means f of x. My problem uses f of x, so that's great. So f of x. Okay, we said that our m is 3, so I'm just going to write that here so I have it. The only piece that I am missing is my b. Remember, your b is where x equals 0. So if I look at my table, x equals 0 right here. So at the start, the dog weighed 5 pounds. Now I can plug in my numbers to create my equation. So I'm going to have 3x plus 5. Okay, part E says explain the meaning of f of 4 equals 17. So when I have something like this, you see how the x is inside the parentheses? That means that the 4 represents the x. So then the 17 represents the y. If I look at my table, x is being represented by the number of years. Okay, so this is my x and this is my y. And my y is represented by the weight of the dog in pounds. So if I find 4 in my x row, 4 is right here. And the 17 is right underneath it. So this is saying in 4 years, the dog will weigh 17 pounds. So let me write that. So in 4 years, the dog will weigh 17 pounds. Okay, what is the domain of the graph? Domain is your axis, so from left to right. So domain is the axis. So because of this, we have a start, but we don't necessarily have an end. So we're just assuming the dog just gains weight forever and ever and ever. So because my domain is my x's, I'm going to say x. Because my dog is increasing, right, as the years go by, and I start at year 0, this is going to be x is greater than or equal to 0, right? Because x can be 0, x can be 1, x can be 2, 3, 4, 5, etc., right? It just goes on. Your range is your y's. If I look at my y's at my table or at my graph, you see how I don't start at 0? I actually start at 5. So my range is going to start at 5 and it's going to increase, right? Because my dog is gaining weight. So for my range, it's y is greater than or equal to 5. When will Barbara's dog weigh 50 pounds? So that equation that we wrote up above in part D, I'm going to rewrite it here. Remember, weight is being represented by f of x. In my table, I see that right here. So that means that f of x equals 50. So that means that this f and this x will be replaced with 50. Okay, so let me write that equation. So 50 equals 3x plus 5. So I'm solving for the years. I'm solving for x. So this is a two-step equation. Okay, subtract the 5, 45, and then I'll divide by 3. So then x equals 45 divided by 3, I get 15. So in 15 years, the dog is going to weigh 50 pounds. Okay, so let's write a sentence saying that. So in 15 years, the dog will weigh 50 pounds. Okay, perfect. Once you have that sentence, you can go ahead and turn to the next page. Okay, so there's this try it that is on the page. What I would like you to do is I would like you to pause the video right here and try this problem about Max and his houseplant. So you're going to pause, and then once you feel like you have all of it, go ahead and unpause because I'm just going to show you the answers, okay? I'm not going to go over it. So here is what you should have gotten. So you know that the plant starts at 15 centimeters and it's growing 2 centimeters tall every week. So the top is +1, the bottom is +2. Okay, then you can figure out, right, how tall it'll be in 10 weeks. And then you can write your equation in function notation. So here's how you identify your slope. Your start is where x equals 0, and then here's your final equation. Okay, perfect. I'm going to skip to 2.3 now. Okay, so today for this lesson, I should say we're building linear models. So you have a graph, and we're going to pull information from the graph. So the x-axis is the figure number, and the y-axis is the total number of tiles. So part A says how many tiles are there in figure 0. So figure numbers on the bottom, here is 0. I'm going to go up until I hit my line, and I hit it right here at 3. So there are going to be 3 tiles in figure 0. There's not a lot of space for a sentence, right? Normally we would want a sentence with a question, but we can just write 3 tiles. Remember, growth rate is just a fancy word for slope. So here you want to pick 2 points, and you want to count your rise over your run. So you can pick any 2 points you want. So I'm going to pick this one and this one. Okay, let me zoom in a bit. Okay, and then you want to draw your triangle. So here's my triangle. Okay, remember, if you go up or to the right, it's positive. If you go down or to the left, it's negative. And it's always your y over your x. So it's always the up, down number over the left, right number. So then here, it looks like I'm going up 1, 2. So I'm going up 2, and I'm going to the right 1. Always look at the numbers on the side because that can change what these numbers are. So my growth rate is always the y over the x. The y is plus 2. The x is plus 1. In your calculator, you can go ahead and see if that simplifies. So 2 divided by 1 does give us 2. Okay, so my start is where it hits on the y-axis, and we said that our starting number of tiles was 3. Okay, so that's my b. My m, we just said, was 2. So when I write my equation, because it's always in the form of y equals mx plus b, I have y equals, m is 2 because that's my growth, and b is 3 because that's my start. Okay, let's try the next example. So same thing here. You want to see what figures, how many tiles are in figure 0. Okay, that's also where your y-intercept is, or what your start is. If I look at figure 0 and I go up until I touch it, it starts at 3. So this is also 3 tiles. Then to find my growth, again, which is your slope, you need to pick 2 points. Since I already have a point here, I just have to find another point, so I'm going to pick this one. Then I'm going to draw my triangle. I'm going to calculate how many up I go. So I start here, I go up 1, 2, 3, 4, 5, 6. So I go up 6. And I go to the right 1. So then when I'm writing my growth, it's always your y over your x. So the up down number over the left right number. So plus 6 over plus 1. If you put that in your calculator, 6 divided by 1, I get 6. Okay, when I'm writing my equation, function notation, remember, means f of x. So this is f of x. Okay, if I look at the previous one, I want it to look like this, right? However, I'm just using f of x this time. My b is my start. And we said we were starting with 3 tiles. And my m, we said, was 6. So I'm going to write 6 here. And if I want it to look like this, it's going to be 6x plus 3. Okay, and then part D, very similar to the one that we did on the previous page. So you see how the x is in the parentheses? That means the 1 is the x and the 9 is the y. X is my figure number, right? Because that's my x-axis. Y is the number of tiles. So this is saying at figure number 1, there are 9 tiles. So at figure number 1, there are 9 tiles. So let me write a sentence saying that. In figure 1, there are 9 tiles. Okay, perfect. Once you have that, let's go ahead and go to the last page, and then that'll be the last part of this video for today. Okay, so now we're going to think about tables. Tables, you can also pull your M and your B and figure out what your equation is. Okay, so on the top, you see how I'm going up 0, 1, 2, 3. So on the top, I'm going up by 1. Okay, so my change in X is plus 1. On the bottom, I see that I want to go up by 5, so I'm just going to do negative 2 plus 5, which gives me 3. And I'm going to continue that pattern. So 3 plus 5 is 8. 8 plus 5 is 13. Okay, I'm just going to continue that pattern. So then this is 18, 23, and 28. My change in Y is what I'm doing each time, which is adding or plussing 5. So I'm going to write plus 5. Okay, perfect. So then here it tells you what is the y-intercept of the line. Remember, your y-intercept is where x equals 0. So I'm going to look for that in my table, and I see that right here. Remember, intercept means a point, so it has to look like this. Right, specifically for the y-intercept. So for me, it's going to be 0, negative 2. So I'm going to write 0, negative 2. Remember, growth rate is just fancy for slope. Your slope is always y over x. My y here is plus 5. My x here is plus 1. If I put that in my calculator, 5 divided by 1, I get 5. Okay, to write my equation, function notation means f of x. But always look at your table, always look at your problem if they tell you what letters, what variables to use. So I see the f of x there, and I'm using x. Okay, so I'm going to have f of x. Okay, I know that my m is 5, so I'm going to write that on the side. However, my b remembers wherever x is 0, and x is 0 right here where it's negative 2. So I have my m and I have my b. Remember, your equation always looks like this. So because I'm using function notation, it's f of x. My m is the number 5. I'm using x, right, because my problem tells me that. And my plus b is going to be minus 2. So that's my final equation. Okay, so for the try it at the bottom, I would like you to pause the video. I would like you to try it by yourself. And then when you feel like you got it, I'll show you the answers. And then you can compare yours with mine. So this is what I got for the try it. So the top row is going up by 1. The bottom row is going up by 2. And then you can fill in the rest of the table. Your y-intercept, remember, is where x equals 0. So that's at this point right here, 0, 3. Your growth rate is your y over your x. So 2 over 1 simplifies to 2. And then you're doing function notation again. You have your b, you have your m, and so you can write your equation right here. Okay, perfect. So we're going to stop there for today, and then we'll pick up the rest tomorrow.